Can you tell how bright this is, the new light bulb?
Oh yeah, it's like blinding.
It's awesome.
It hurts my eyes.
So elevation,
Gives me depression.
Try to eat elevation.
thank you.
That's right.
Angles of elevation is basically what we did last Tuesday. It's line of sight. Line of sight is what your eye level's at. Your line of sight is always parallel to the ground. And it's your line of sight looking up. This is what you call an angle of elevation. It's line of sight up. Okay? So, can you put away your phone, please? I know you've been gone for a while. Can you just not worry about it for a while? Please and thank you. Thank you. So you got your line of sight up is elevation. And depending upon the style problem or whatever you're looking at, like we did last week, you know how we had line of sight where we added in our 60 some odd inches or whatever it was for how far off we were from the ground. Sometimes you'll have to do that depending on how the problems give it to you, or sometimes it'll say an angle of elevation with the ground. So that means it's brought down to the ground, so you don't have to worry about that. But that angle of elevation is always what you're considering line of sight looking upward. Really, really, really easy example of something that this looks like is this. You're flying a kite. The kite has a 100-foot string. Guys, please, enough. The angle of elevation of the string is 52 degrees. How high off the ground is the kite? What happens here is that you're going to be given a bunch of information. You just have to draw pictures for it. That's it. So, I'm assuming most of you guys have all flown a kite before.
No.
I'm hoping.
No.
I didn't have
Well, if you're saying that the kite string is 100 feet, yeah, it's only take one. Thank you guys. You're talking about the kite string being 100 feet long. Which part of this do you think that is? The horizontal, the vertical, or the hypotenuse for the kite string? Hypotenuse. This case, we're talking about kite string, and kite string is holding the kite. Really, really bad kite, sorry. I'm not even going to try that one. It says that it is so many degrees off the ground. What angle do you think that is? The bottom one or the top one? Bottom. Angle of elevation from the ground. How far or how high up in the air is the kite? Is that your horizontal or your vertical? What trig function are you going to use? Sine, very good. And you're going to use sine. So basically what's happening here, guys, is you're just going to take information that's given to you, draw a picture, figure out what trig value you use, and solve it through. So it means the sine then of 52 is x over 100. Now I know that all of you know how to solve that because you showed me. Write it out prior to what you would put in your calculator, which means you would do what to both sides? Multiply by 100. So you have 100 times the sine of 52 is your vertical height. And then it's a matter of just rounding it out to 2 decimal places. Okay? When you do this, please, 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 please make sure that you are in that degree mode. And usually people don't have too much to worry with that, but I have seen somebody who's using excuse me, a different calculator when they were at home, or if they were using one on their phone and they didn't change the mode, it could mess with your values. So you always write down what you're going to put in the calculator before you put the calculator. Okay? What do you get per decimal? 78. There you go. And that's what we're looking at being able to do. Can you take a bunch of information and write it out? Yes, ma'am.
So like we're
starting from that corner and then so that's like a string.
Mhm. You have to visualize the picture. That's it.
But you start from that corner.
I could have had it drawn. I could have drawn it, flying my kite this way if I wanted.
Yeah, so like it just depends on what side the triangle.
Yeah.
Okay.
Yep. You can fly it this way. You can fly it that way. It's still your angle of elevation. Shh, guys. Angle of elevation is still degrees off the horizon. That's it. Sorry, this one didn't work was very well. Height of a tree. You want to figure out how tall a tree is. You start by finding a tree. You find a tree. You walk 100 feet away from the tree. When you walk 100 feet away from a tree, if you're walking 100 feet away from the tree, are you walking a horizontal, vertical, or a diagonal distance when you're walking away from a tree? Horizontal. So you walk away from a tree, and you're over here. You're away from the tree. How far away from the tree are you? Apparently you've got chopped in half too. You are 100 feet away from the tree. A lot of times the easy thing to remember is when you use a tape measure, do you use that horizontally or are you going to use it vertically? Or on a diagonal, I should say. Usually when you're measuring out distances, you're measuring them on a flat surface, and you're using that horizontal distance for a tape measure. Excuse me. And it says that, well, apparently you're, bless you. You happen to have a handy dandy clinometer on you, and you look up toward the tree, you find that you have an angle of elevation of 33 degrees. Now, if I'm going to figure out how tall said tree is that an opposite, adjacent, or a hypotenuse for the height of the tree? It's an opposite. Very good. What trig function am I going to use to find an opposite, knowing that I have its horizontal or its adjacent? Tangent. Very good. And no, it's not always 100 feet away. It's not always miraculously 100 feet away from something. And once again, you're back to the same exact thing that you guys showed me last week. You know how to do. Always write out what you're going to do prior to doing it. We had a good example of why we should do that during fourth hour. We had a student type, he wrote all this out, but he got the wrong answer because he accidentally typed in 55 degrees instead of 53. He just bumped the button twice by mistake. He's like, wait, why am I off? And then I went and looked at his paper, I'm like, oh, and I was able to figure out just by checking his numbers because he was so close to do it that way. Yes, sir?
So when you have to add like your height to the tree.
If it's not given to you then like that, you can always say that it's making the angle from the ground. There are times that it will have something like that thrown in there, and it's going to be obvious. It'll say like Steve is 6 feet from the ground from his eyesight, and he's measuring to the, then you know you back that stuff in and out. Okay. But in this case here, it's so we're trying to make this as generic as possible, as it's just an elevation from the ground. But yeah, you're right. It's not rocket science we're trying to do. Yes, ma'am. Yeah. Sometimes you'll find out what the angle is too. We can do anything. We can figure out how far away we are from an object. Bless you. We can figure out the angle. We can also figure out how tall something is. It just depends on the information given to us. And I think I have examples of like all three of them, so. You're always so pessimistic. Hi, Tope.
By the name?
Oh, this one's scary. An airplane. And this not a great one. You should. An airplane is flying at a height of 2 miles above the ground. The distance along the ground from the airplane to the airport is 5 miles away. what would the angle of depression be? Oh, hey, what's going on? The angle of depression is different. Angle of depression is line of sight looking downward. Angle of depression is line of sight downward. Whereas angle of elevation was line of sight up, this is line of sight down. Now, line of sight, like we've said before, line of sight is always parallel to the ground. Excuse me. Line of sight is always parallel to the ground, which means that if this angle is the angle of depression, it's also this angle here, because if parallel lines cut by a transversal, alternate interior angles are congruent. So you get this idea of the angle of depression going down would be the exact same thing as the angle of elevation looking back up. The two angles are always going to be the same. It's just how they're drawn into the diagram. That's what's different. Okay? That's the only difference here. Angle of depression, line of sight down. Angle of elevation, line of sight up. That's it. Okay? So what happens in a problem like this then is that you've got your airplane boy, I think that's good. You have your radar tower, the window case. You get to draw cool pictures like this. I know you're embarrassed for me because you are the artiste. So again, if I'm talking about angle of depression, let me put this on a clean one then. I have my airplane.
One on the board behind you. I just do this just yeah. You gotta have it more round at the front. I agree with you. Okay, I think I'll go with that.
Better than nothing.
Let's go with that.
We have our there's the tower. If an airplane is 2 miles off the ground, is that it's vertical, horizontal, or diagonal? So it's vertical. So it's 2 miles up. If it's 2 miles up, then it says then it is 5 miles from the airport along the ground. It's the horizontal. It's pretty obvious. You're trying to figure out what the angle of depression is, which is this part here. Angle of depression is the same thing as the angle of elevation here. So remember, when you draw these, line of sight down, remember, it's the same thing as line of sight up. You flip it. So in this case, then 2 becomes my, excuse me, 2 becomes my opposite, 5 is my adjacent. What trig value is that going to be? Tangent. Now I need to find the angle in this case, because it's asking to find the angle of depression. So that means the tangent of theta, remember it's just my angle, is 2/5. What do you write that out as then to get it by itself?
Inverse.
Very good. Theta equals the inverse tangent of 2/5. Okay? Oh wait, no, this was the one that the kid wrote down the wrong number. He changed the 5 to a 4. I remember that now. So write down what you're going to put in the calculator before you do it. When you do that, it shows that you know what you're doing. That was the main reason why I kept having you guys do that last week, over and over and over again. So now if you hit the buttons, then what do you get for an angle? 21.80? So that's this here, 21.80, which means it is 21.80. And that's how this is going to work. Okay? Not so scary, is it? It is fairly easy. Yes, ma'am.
So when you're doing the elevation, you start on the side opposite than the right angle. Then when you're doing depression, you start at like the side of the right angle.
That's a good way to think of it, yeah. That's a good way to think of it. Yeah.
I'm just trying to make sense of it.
Yeah, there's a bunch of ways you can think. That's a good way to think. That works. I'd say that I think that would work pretty regularly.
Okay.
Let's try another one. A little bird. A little bird is sitting on top of a lamppost. Not much like that bird. Ha ha! I made you look. So there's a bird. There's a bird up on a lamppost. Lamppost.
What is that?
It's a lamppost. It looks just like that.
Was there a bird on it too?
I haven't gotten that far.
What kind of bird is that? That is a bird. That's not a bird. That's like a banana.
It's a bird.
It's a banana.
No, that's a plane.
No, it's not.
Yeah.
No, wait, ready for it? This is a plane. Geometry. So there's your bird. Actually, kind of looks like a penguin about to fall over. The bird, the angle of depression from the bird to the feet of an... Yes, ma'am. Yes, ma'am. The angle of depression from the bird to the feet of an observer.
That's me. Huh? Oh.
The angle of depression from the bird to the feet of the observer.
Why is he looking? He says, "What are those?" That's old. That was old. No one laughed.
This angle is 35, because you know birds know how to measure degrees and angles and stuff. They're very smart. That's why I chose the penguin, the smartest of the birds. Actually, wait a second. How did a penguin get up on a lamppost? They can't fly. I just realized that nobody even called me out on penguins can't fly.
I literally just.
All right. The distance from the bird to the observer is 25 meters. Now,
Why is that like lamppost to human ratio?
what I want you guys to think of is when we talk about distances,
I just do like a little.
when we measure distances, think about it using a tape measure. You can use a tape measure going vertical, you can use a tape measure going horizontal, but we normally don't use tape measures to go on a diagonal distance. So, unless they give you a diagonal like you have, like on a string one where you have the rope for the kite, then you would use that for your diagonal. Now, if I'm saying that it's 25 meters from that would be this part. How tall is said Lamppost. Well, I'm trying to find that. So if my angle of depression is 35, what's it down here?
35.
There you go. What trig function are you going to use? Am I trying to find a diagonal? Trying to figure out how tall the lamppost is. Tangent. I want to use tangent because the value of the height is my opposite. This is my adjacent, so I use tangent. And it's a matter of just putting it together. Okay. Yes, you can be kind of silly and goofy on some of these pictures because, you know, that's what you do.
Are you gonna make us like draw out like this?
You know, you don't have to draw a penguin on a lamppost, but if it helps you visualize the problem more, go for it. But my thing is that I still want you to draw something, okay? You can get away with just knowing that you have a lamppost that's up. You know, you have a lamppost that's up here, you're this far away, you know that the depression is this much, is 35, which means this is 35. I mean, that's kind of like your bare bones of what you'd have to do to figure out the problem.
Wait, when you say the 35 is depression, is that whole line?
It's this angle here. Remember, the angle of depression is line of sight looking down. So that's this angle here, okay? And then we flip it to the inside then for the inside triangle. They just press buttons, round it out. Oh, I got one. So you don't have to write it out. I'll have you guys draw it off this. Yes, ma'am. What's that? Are you getting the genes too? Isn't it awful? It's terrible. It's so bad. Are you feeling better? I know. See, yeah. That was like the part, that was what, Tuesday? Or no, Wednesday? It's awful. I'm 2 weeks going on this cough. 2 weeks already. It's finally today is the first day I almost feel normal. You want to run the bathroom? So let's take a look at number 2. Let's take a look at number 2. Spares? An airplane takes off 200 yards from a 60-foot building. Do you need one?
No, again, he's born. Yes, it is.
Exactly, thank you. So if an airplane is taking off 200 yards away from a building, that means we have to figure out what a building looks like. Well, I didn't say a word. The building is how tall? 60 feet. Excuse me. You guys, we discussed what that single tick mark means for measurements, right?
Yeah.
Feet.
This means this is 60 feet. This would be 60 inches. This would be 60 feet, 3 inches, and so on. So that's 60 feet. It tells you the airplane is taken off 200 yards away. You need to figure out the angle that it has to be able to clear the building. So what happens here is that two things. First of all, notice that you have units in different measures. We don't want that. So what we have to think of is that we have to convert to the same units of measure. Remember, it's always easier to convert to the smaller of the two. In this case, it really doesn't matter, but if you have feet and inches, it's usually more of an issue. But if you go this route, it's just going to be cleaner, plus you don't have to worry about decimals and junk like that, okay? How many feet are in a yard? 3. So what's 200 times 3? So what trig function am I going to use to figure out what theta is? Very good. Tangent. The tangent of theta is 60 over 600. Excuse me.
So, Mr. Murphy, if you did just leave it, would it still work or no?
No, because then you're comparing two different dimensions. Whenever you have fractional things, when you're talking, remember this is ratios. Ratios have to be within the same dimensions. They have to have the same units of measure. So we haven't really worried so much about it, but every once in a while with these styles, you'll see that they'll throw feet with one of them, yards in another, something they might put things in inches. So in order to compare them, they have to be in the same unit of measure. That's all. Again, to find the angle, what's the angle of ascent? 5. What? 60? I think you have to press the wrong button.
5.71. 5.71.
Oh, you didn't do it. You have feet and yards. You got it in the same dimension. Put both feet or both yards. That's why you're getting wrong. What'd you guys get? 5.7 something?
5.71.
So in order to clear the building, what? Why are you laughing at me? Can't you have a little bit of fun with this? I'll change it around again. All right, take a couple minutes, do the next two. The ladder and the ramp. Oh my. Shh. Guys, take a couple minutes, try these two out, okay? I'll be right there. So, real quick, when you have a ladder, somebody was arguing with me about this. Relax.
Sorry.
So was arguing with me about this last hour. We're not talking about an A-frame ladder, ladies and gentlemen. We're just talking about a plain old boring ladder that you lean up against the wall.
Oh.
So stop overthinking it. Here's a wall. The wall is 13 feet tall. The ladder to reach the top of the ladder, or whatever that's called, is 14 feet.
Oh, what? I had that right. Oh, I had it.
What's the angle? What trig function are you going to use? Fine, good.
Oh, yeah. Fine.
Wait, are you leaning
Yeah.
immediately against the wall?
Yeah. You've never climbed a ladder?
I'm really. I'm like.
There's that. Very straightforward, okay? Guys, and then lastly, before we run out of here, a ramp is needed to allow a vehicle to climb a 2-foot wall. The angle of elevation in order for the vehicles to safely go up must be 30 degrees or less. The longest ramp available is 5 feet. Can this ramp be used safely? So here's what happens. You've got a 2-foot wall. You have a 5-foot ramp. What angle are you finding? Well, we know this has to be a right angle. This one isn't it. So it has to be what trig function? Sine again. This is actually a practical problem, believe it or not, and I'll show you why in a second. And once again, it's a matter of when you're trying to find the angle, that's the only time that you wind up hitting the inverse button. Is that less than 30?
Yeah, so it's safe.
23 point something?
Yeah, 58. 8.
And then you know it's going to be okay. Now the reason why I said this is actually a practical application here is if you've ever tried to load something in the back of a pickup truck on a ramp. Some of you may or may not have ever tried to put a motorcycle or a couch, well, I wouldn't worry about a couch, but so here's your truck. And then here's your tailgate.
This looks so awful.
You might want to put headlight for the window, maybe it's harder.
This is probably about 2 feet off the ground. And then you want to put a ramp up it so that way you're not trying to fall over and die as you're pushing up. Your motorcycle rolling up the ramp. Again, this is why I kind of have a degree in math. I wouldn't, you know, sometimes you guys might want me to verify that for you, but finish this worksheet for tomorrow. All right, finish this one for tomorrow. Yes, ma'am.